A galaxy is a gravitationally bound system of stars, stellar remnants, interstellar gas, dust, and dark matter. The word galaxy is derived from the Greek galaxias, literally, milky, a reference to the Milky Way. Galaxies range in size from dwarfs with just a few thousand stars to giants with 100 trillion stars, each orbiting their galaxy's own center of mass. Galaxies are categorized according to their visual morphology, including elliptical, spiral, and irregular. Many galaxies are thought to have black holes at their active centers. The Milky Way's central black hole, known as Sagittarius A*, has a mass 4 million times greater than the Sun. As of July 2015, EGSY 8P7 is the oldest and most distant observed galaxy with a light travel distance of 13.2 billion light-years from Earth, and observed as it existed 570 million years after the Big Bang. Previously, as of May 2015, EGSZS 8-1 was the most distant known galaxy, estimated to have a light travel distance of 13.1 billion light-years away and to have 15% of the mass of the Milky Way. Approximately 170 billion to 200 billion galaxies exist in the observable universe. Most of the galaxies are 1,000 to 100,000 parsecs in diameter and usually separated by distances on the order of millions of parsecs. The space between galaxies is filled with a tenuous gas with an average density less than 1 atom per cubic meter. The majority of galaxies are gravitationally organized into associations known as galaxy groups, clusters, and superclusters. At the largest scale, these associations are generally arranged into sheets and filaments that are surrounded by immense voids. Etymology. The origin of the word galaxy derives from the Greek term for the Milky Way, galaxias, or kyklos galaktikos, due to its appearance as a milky band of light in the sky. In Greek mythology, Zeus places his son born by a mortal woman, the infant Heracles, on Hera's breast while she is asleep so that the baby will drink her divine milk and will thus become immortal. Hera wakes up while breastfeeding and then realizes she is nursing an unknown baby. She pushes the baby away, some of her milk spills and produces the faint band of light known as the Milky Way. In the astronomical literature, the capitalized word, galaxy, is often used to refer to our galaxy, the Milky Way, to distinguish it from the other galaxies in our universe. The English term Milky Way can be traced back to a story by Chaucer c. 1380. See yonder, lo, the galaxy which men clepeth the Milky Way, for it is white. Geoffrey Chaucer. The House of Fame. Certain astronomical objects known as spiral nebulas such as M31 would later be recognized as conglomerations of stars when the true distance to these objects began to be discovered, and they would be deemed island universes. However, the word universe was later understood to mean the entirety of existence. So this expression fell into disuse and the objects instead became known as galaxies. Nomenclature. Tens of thousands of galaxies have been catalogued, but only a few have well-established names, such as the Andromeda Galaxy, the Magellanic Clouds, the Whirlpool Galaxy and the Sombrero Galaxy. Astronomers work with numbers from certain catalogues, such as the Messier catalogue, the NGC, the IC, the CGCG, the MCG and UGC. All of the well-known galaxies appear in one or more of these catalogues, but each time under a different number. For example, Messier 109 is a spiral galaxy having the number 109 in the catalogue of Messier, but also codes NGC 3992, UGC 6937, CGCG 269023, MCG plus 0920044, and PGC 37617. Because it is customary in science to assign names to most of the studied objects, even to the smallest ones, The Belgian astrophysicist Gerard Baudife and the classicist Michel Berger started a new catalogue in which 1,000 well-known galaxies are given meaningful, descriptive names in Latin in accordance with the binomial nomenclature that one uses in other sciences such as biology, anatomy, paleontology, and in other fields of astronomy such as the geography of Mars. One of the arguments to do so is that these impressive objects deserve better than uninspired codes. For instance, Baudife and Berger propose the informal, descriptive name Callimorphus Ursa Majoris for the well-formed barred galaxy Messier 109 in Ursa Major. Observation history. The realization that we live in a galaxy, and that ours is one among many, parallels major discoveries that were made about the Milky Way and other nebulae in the night sky. Milky Way. The Greek philosopher Democritus proposed that the bright band on the night sky known as the Milky Way might consist of distant stars. Aristotle, however, believed the Milky Way to be caused by the ignition of the fiery exhalation of some stars that were large, numerous and close together, and that the ignition takes place in the upper part of the atmosphere, in the region of the world that is continuous with the heavenly motions. The Neoplatonist philosopher Olympiodorus the Younger was critical of this view, arguing that if the Milky Way is sublunary it should appear different at different times and places on Earth, and that it should have parallax, which it does not. In his view, the Milky Way is celestial. According to Mohanna Muhammad, the Arabian astronomer Al-Hasan made the first attempt at observing and measuring the Milky Way's parallax, and he thus determined that, because the Milky Way had no parallax, it must be remote from the Earth, not belonging to the atmosphere. The Persian astronomer al-Biruni proposed the Milky Way galaxy to be a collection of countless fragments of the nature of nebulous stars. The Andalusian astronomer Ibn Bajjah proposed that the Milky Way is made up of many stars that almost touch one another, and appear to be a continuous image due to the effect of refraction from sublunary material, citing his observation of the conjunction of Jupiter and Mars as evidence of this occurring when two objects are near. In the 14th century, the Syrian-born Ibn Qayyim proposed the Milky Way galaxy to be a myriad of tiny stars packed together in the sphere of the fixed stars. Actual proof of the Milky Way consisting of many stars came in 1610 when the Italian astronomer Galileo Galilei used a telescope to study the Milky Way and discovered that it is composed of a huge number of faint stars. In 1750, the English astronomer Thomas Wright, in his An Original Theory or New Hypothesis of the Universe, speculated that the galaxy might be a rotating body of a huge number of stars held together by gravitational forces, akin to the solar system but on a much larger scale. The resulting disk of stars can be seen as a band on the sky from our perspective inside the disk. In a treatise in 1755, Immanuel Kant elaborated on Wright's idea about the structure of the Milky Way. The first project to describe the shape of the Milky Way and the position of the Sun was undertaken by William Herschel in 1785 by counting the number of stars in different regions of the sky. He produced a diagram of the shape of the galaxy with the solar system close to the center. Using a refined approach, Cat 10 in 1920 arrived at the picture of a small ellipsoid galaxy with the Sun close to the center. A different method by Harlow Shapley based on the cataloguing of globular clusters led to a radically different picture. A flat disk with diameter approximately 70 kiloparsecs and the Sun far from the center. Both analyses failed to take into account the absorption of light by interstellar dust present in the galactic plane. But after Robert Julius Trumpler quantified this effect in 1930 by studying open clusters, the present picture of our host galaxy, the Milky Way, emerged. Distinction from other nebulae. A few galaxies outside the Milky Way are visible in the night sky to the unaided eye. In the 10th century, the Persian astronomer al-Sufi made the earliest recorded identification of the Andromeda Galaxy. describing it as a small cloud. In 964, Al-Sufi identified the Large Magellanic Cloud in his Book of Fixed Stars. It was not seen by Europeans until Magellan's voyage in the 16th century. The Andromeda Galaxy was independently noted by Simon Marius in 1612. In 1750, Thomas Wright speculated that the Milky Way is a flattened disk of stars, and that some of the nebulae visible in the night sky might be separate Milky Ways. In 1755, Immanuel Kant used the term island universe to describe these distant nebulae. Toward the end of the 18th century, Charles Messier compiled a catalogue containing the 109 brightest celestial objects having nebulous appearance. Subsequently, William Herschel assembled a catalogue of 5,000 nebulae. In 1845, Lord Rosse constructed a new telescope and was able to distinguish between elliptical and spiral nebulae. He also managed to make out individual point sources in some of these nebulae, lending credence to Kant's earlier conjecture. In 1912, Vesta Slipher made spectrographic studies of the brightest spiral nebulae to determine their composition. Slipher discovered that the spiral nebulae have high Doppler shifts, indicating that they are moving at a rate exceeding the velocity of the stars he had measured. He found that the majority of these nebulae are moving away from us. In 1917, Heber Curtis observed Nova S Andromeda within the Great Andromeda Nebula. Searching the photographic record, he found 11 more novae. Curtis noticed that these novae were, on average, 10 magnitudes fainter than those that occurred within our galaxy. As a result, he was able to come up with a distance estimate of 150,000 parsecs. He became a proponent of the so-called island universes hypothesis, which holds that spiral nebulae are actually independent galaxies. In 1920, the so-called Great Debate took place between Harlow Shapley and Heber Curtis, concerning the nature of the Milky Way, spiral nebulae, and the dimensions of the universe. To support his claim that the Great Andromeda Nebula is an external galaxy, Curtis noted the appearance of dark lanes resembling the dust clouds in the Milky Way, as well as the significant Doppler shift. In 1922, the Estonian astronomer Ernst Öpik gave a distance determination that supported the theory that the Andromeda Nebula is indeed a distant, extragalactic object. Using the new 100-inch Mount Wilson telescope, Edwin Hubble was able to resolve the outer parts of some spiral nebulae as collections of individual stars and identified some Cepheid variables, thus allowing him to estimate the distance to the nebulae. They were far too distant to be part of the Milky Way. In 1936, Hubble produced a classification of galactic morphology that is used to this day. Modern research. In 1944, Hendrik van der Hulst predicted that microwave radiation with wavelength of 21 cm would be detectable from interstellar atomic hydrogen gas, and in 1951 it was observed. This radiation is not affected by dust absorption, and so its Doppler shift can be used to map the motion of the gas in our galaxy. These observations led to the hypothesis of a rotating bar structure in the center of our galaxy. With improved radio telescopes, hydrogen gas could also be traced in other galaxies. In the 1970s, Vera Rubin uncovered a discrepancy between observed galactic rotation speed and that predicted by the visible mass of stars and gas. Today, the galaxy rotation problem is thought to be explained by the presence of large quantities of unseen dark matter, a concept known as the universal rotation curve of spirals, moreover, shows that the problem is ubiquitous in these objects. Beginning in the 1990s, the Hubble Space Telescope yielded improved observations. Among other things, Hubble data helped establish that the missing dark matter in our galaxy cannot solely consist of inherently faint and small stars. The Hubble Deep Field, an extremely long exposure of a relatively empty part of the sky, provided evidence that there are about 125 billion galaxies in the universe. Improved technology in detecting the spectra invisible to humans allow detection of other galaxies that are not detected by Hubble. Particularly, galaxy surveys in the zone of avoidance have revealed a number of new galaxies.